question?
Actually, so the question about the memory map thing.
Yes.
Have you always been able to flush the memory before it filled? Because otherwise, you can toast. If you get to the end of the memory, it hasn't finished the flush operation, you're out of luck.
Yes. So what we do, so the question was, well, when do you flush the memory? Because you don't want to end up in the situation where you, well, fill the whole memory and then you don't know what to do. So what we do is, before we store a packet in the memory map region, we check whether there's enough space left. And if there is no space left for it, then we flush it and start over again with a new region. So this, well, I will also show you in the demo, but for example, if your memory region fits, like, say, 1,000 packets, then you only access hard drive every 1,000 packets, which is, of course, a good thing. Okay, you should know most of these options because it's what you need in every sniffer application. The snaplen specifies the number of bytes you want to capture from the network stream. For example, if you're not really interested in the whole packet, but only in the header or something, you might specify a 60 here, and then you will only capture 60 bytes instead of the whole packet. If you specify a 0 here, then you capture the whole packet. This is the rotate option again. You can override these by specifying them again in the tracker configuration, and then you have the path argument in the file pattern again. And you can also put the tracker in promise mode, so in promiscuous mode, to also record traffic that is not distant to the IP addresses that belong to this host. And the nice thing is that you can have as many of these as you want. You can have one for TCP, you can have one for IPv6, you can have one for ICMP, you can have one for DNS, and so on. And that's really, really cool. Okay? Demo time? Yes, demo time. I think I have to drop the microphone for that. Let's see how that goes. I'll try it without the microphone. So I think it's not being taped then, but well. Okay. Let's have a look at some tracker configuration. I think it's going to work like that. Okay, so this is more or less the configuration you've seen on the slide. Okay, it's sniffing on the loopback interface. The snaplen is set to a value that also fits on, what's the name again? Jumbo frames, like the big frames on Ethernet. Okay, and we will store trace files in the temp directory, the temp folder, and this is the format string for the file name. And I will just, well, start multicap, and you can see that it actually works. All right, obviously you need root permissions for it, because it tries to open this peer packet socket, which is only permitted at root. Okay, can you read this, or do you want me to increase it? Okay, so what you see here is some logging. You can also increase the log level to get some debug output if you want to debug the application if you think it's not working or something. You can see it reads the configuration, creates the tracker, and then it reports that it's storing packets in the single, and then it has filled in the date in here. And it also appended a number, an index number. Okay, so let's just generate some traffic. Netcat listener 1, 2, 3, 4, and we connect it and send some stuff like I trade foods for O-days, a phrase you usually see on the interwebs. Okay, and if we terminate it, we see that it has recorded, well, let me put that up a bit. The bottom down here, you see that it outputs some statistics. It has recorded 16 packets, and the drop rate is 0. Ooh, unfortunately. If this would not be 0, okay. And we can now, so this is the data capture tool, right? So we have now captured some traffic, and we can now fire up our favorite analysis tool and do some analysis on this trace file. For example, Wireshark. So this is Wireshark, and we see the packets in here. We can follow the TCP stream, and we see it, well, can reassemble it, and we can now start to analyze and mine the data. Okay, I mean, if you wonder how this is really different from daemon logger TCP dump, these two, just give it a try, play with it, and we haven't done an extensive performance comparison, but to us it works a little bit better. 10 minutes? Okay, I'll go over time. Okay, real quick, this was the multicap part. Now I want to talk about another utility we developed recently. Actually, it's brand new. It was released last week. It's called Streams. And it's called Streams because it's a new utility. I can use the microphone again. It's called Streams because it's used for analyzing TCP streams. Is everybody aware of what the stream is, a TCP stream? Some are nodding, some are thinking.
Explain the concept first.
Yeah, I'm always asking the question first, then I'm explaining the concept, and then... Okay, so a TCP stream, I mean, if you want to send data over a network, in most cases you want to have a stream. That means you want to have ordered data, right? So you want to write you want the data to arrive in the same order, and you also want to make sure that no data is left out or dropped or deleted in between or during the transmission. So let's imagine these are some TCP segments, and there are of course some other packets in between, other TCP segments, other connections, UDP, IP, whatever. And when you receive this data, you want to reassemble the ordered stream again down here. You see, it's not really in the right order here because of, I don't know, laggy networks or whatever. And you want to reassemble the full stream, the complete stream again. Also, if some of these packets gets dropped, then the transmission control protocol makes sure that it's being retransmitted and all these things. So you end up with a stream. And for us, it would be a cool thing if we could sniff those packets and then reassemble the streams ourselves. It's actually the thing I did just with Wireshark that showed the line I typed. So we want to reassemble those streams, and then we want to process them with our analysis tools. Okay? So, of course, you can use Wireshark just the same way I used it a minute ago, or you can use a variety of other tools. Let me see, are they on this slide? Here they are. Okay, here you have it in written form again. A stream is a reliable ordered stream of data. Well, and you have lots of stream reassembly tools. You have Wireshark, you have TCPIC. Who is familiar with TCPIC? It's a crappy, buggy command line tool. I mean, the concept is really cool, but I had to patch it multiple times. It fails on IPv6, and I don't know. I mean, the concept is cool, but it's unfortunately quite buggy. There is also TCP Flow, which is very similar. It's also a command line tool. Both of these read PCAP files and reassemble the streams and dump these to the file system. But the problem is, I mean, in theory, this is pretty cool, but the problem is, say you have a 100 gigabytes PCAP file or a 10 gigabytes PCAP file with 100,000 TCP streams. Then you end up with 100,000 files on your file system. And that doesn't really help because you have to mine these, you have to find the ones you're interested in, and this is really difficult. So while these tools are, well, more or less okay, and they have their use cases or application, I find them somewhat problematic when it comes to analyzing huge packet trace files.
So I'm going to use TCP trace?
Sorry, say again?
Do you use TCP trace?
TCP trace, yeah, I use it and I like it, but it's, as I said, it produces tons of files on...
at least do a summary first and then dig out the flows.
The thing is, I mean, it's the... If you have a PCAP file and you don't know what's in there, then you cannot apply any meaningful filters, and then you have the files, and so it's kind of... Well, it's not as convenient as I wish it was. So, yeah, you see TCP, you see Wireshark down here, the same thing. You can right-click on a packet, select follow TCP stream, and it will show you the stream in hex form in this case. Okay, but we wanted to have something else, so we designed streams. And first of all, I'd like to ask you, just to make sure that you understood the concept of a stream, what do you need in order to reassemble a stream? Can you tell me what you need? In the back.
You need...
Don't read it from the slide.
What? I cannot even read the slide. Anyway, you need TCP sequence numbers to reassemble a stream.
Yeah, but you need the TCP sequence numbers. That's correct, because the sequence numbers encode the ordering, right? It's a sequence index or number, so you can construct or reconstruct the order of the segments. But you also need the IP addresses and ports, because this defines IP endpoint. So this is the information you need. You need the two IP addresses, you need the port numbers, and you need the initial sequence number or the sequence number of the segments, and then you can reassemble the stream. The stream reassembly strategy or policy we chose in streams is printed here. It's only those three things. A SYN segment initiates a connection, or a half-duplex connection, so to speak. This SYN segment starts a new stream. So whenever you receive a SYN segment, this starts a new stream. A reset segment or a fin segment ends a stream or terminates a stream. And any segment gets copied at the right position into the reassembled stream. It's as easy as that. Now, I would expect that some of you guys show up and tell me about this paper down here, this IDS evasion. I think it's the standard publication about IDS evasion. And these two, I think it's two Polish guys, I'm not going to try to pronounce their names. But they talk about reassembly policies in different operating systems. What do you do when you have overlapping segments, right? Which data do you prefer? Can you imagine two overlapping segments? Do you use the data from the first segment or from the later segment? So this is kind of a problem. Or if you have retransmissions, if you have two segments that point to the same offset in the stream, but they carry different data, which data do you use? So that's what these guys are talking about, because you can use these, or you can exploit this for evading intrusion detection systems, but we don't care about that because it's not really relevant in practice. In practice, you don't have retransmissions with different data, or you don't have overlapping segments. Okay? So we just leave that aside. So this is the design principles or the strategy, and then we also wanted to have a command line utility because we want to use it on remote systems, we want to use it on command line, but we also want to have it a convenient tool that allows us to have some degree of interaction.